Electricity. Electricity is beautiful. Isn't that an strange statement? How can something you cannot even see or cannot even touch or hear be beautiful? Yes, you can feel electricity if you ever accidentally touched the live wire and have gotten a shock. But surely that experience was definitely anything but beautiful. What I really mean is the effects, the behavior, and the properties of electricity is really interesting, fascinating, and even extremely useful to us humans. If you happen to live on the 18th floor of a building, just try to avoid taking the lift and climb up the stairs, and you will definitely agree that electricity is beautiful. Now, what is electricity? We cannot see it, touch it, hear it, taste or smell it. The five senses of human body. It also has no mass or weight. Yet, it creates effects that can be observed or experienced. In fact, it can move mountains, and I mean quite literally move mountains. A careful study of various effects of this invisible thing called electricity led us to arrive at some conclusions. Some of these are: there is something called electric charge, which can get added to some object. I will simply call it charge, not the whole thing electric charge from here on. This charge is of two types, called positive and negative. We have devised methods to measure the quantity of charge. The measure of charge is called coulomb. So you can have 1 coulomb charge or 2 coulomb of charge, etc. The quantity of charge is additive, which means if something had 1 coulomb of charge on it and you added another 2 coulombs of charge to it, it will then have 3 coulombs of charge. In fact, most of the physical quantities are additive, like mass, volume, length, and even money. If you ask me to name a non-additive quantity, I can only think about non-physical quantities like happiness, or probably the sweetness. Like if you add 1 teaspoon of sugar and then if you add 1 more teaspoon of sugar, you can't really say that the sweetness exactly got doubled. Another very important thing is positive and negative charges cancel each other, just like addition of signed quantities. +3 added to -2 gives me +1. So many properties of something called charge, which is completely invisible. We also found that this charge can move around, quite similar to water or any liquid. Water can move around through pipes, tubes, and even without any tubes or pipes. You just need to pour a bucket of water on the floor, out of the balcony, or wherever. It will find a path to move or flow and simply move out to different places. However, it has been found that the charge cannot just move out from one place to another through vacuum, air, or on the floor. If there is a ball here carrying some amount of charge on it, and I bring another ball keeping nearby which has no charge on it, this charge cannot just move from one ball to another through air or through vacuum. It moves from one place to another or from one object to another only through some special type of things. Things through which charge can move about or flow are called good conductors. If I were to join them through a piece of rod, still the charge can move from here to here depending on whether this rod is made of good conductor or bad conductor. There are some materials through which charge can flow around. They are called good conductors. There are some materials through which charge cannot flow across. They are called bad conductors. Bad conductors are also known as insulators. The behavior of charge and of water has a lot of similarities. So much so that to understand the behavior of charge, it is often useful to think in terms of water in place of charge. Water flows from high pressure to low pressure. If there are two tanks filled with water, one having water at a very high pressure and the other at a comparatively lower pressure, and we join the two tanks using a thin pipe, the water is being maintained at a high pressure and it is being supplied. If necessary, more quantity of water is being supplied to each tank so that the pressure is maintained. Now you can see water will flow from the tank of high pressure to the tank of low pressure. The equivalent of pressure in electricity is potential. If there is an object having some charge on it at a high potential and there is another object which is kept some distance away which has charge on it at low potential, and we join the two objects using a piece of wire made of good conductor, the charge will flow from high potential to low potential. A water pipe is similar to electric wires made of conducting material. Flow of charge generally through electric wires is called current. Just like water flow rate is measured in amount of water flowing in 1 unit of time. Like liters per second. The flow rate of charge is measured in amount of charge flowing per units of time. And remember, the unit of measure of charge is coulombs. So it becomes coulombs per second. 1 coulomb per second has been given a name called 1 ampere. So 10 amperes current means charge is flowing at the rate of 10 coulombs per second. If high pressure water supply is available, it can be used to do work. For example, turn a wheel. In a turbine, water enters, a high pressure water enters from one side and then goes out on the other side. In the process, it rotates a wheel in the turbine. Similarly, a supply of charge at electrical equivalent of high pressure, which is high potential, can be used to do work. Charge flowing from high potential to low potential, this flow can be used to do work using an electric motor. The electric equivalent of pressure is called potential, an abbreviation for potential of doing work. Electric potential is measured in volts. We know that water flows from high pressure to low pressure. High pressure to low pressure. Water flows from high pressure to low pressure. Similarly, the charge flows, or you can say the current flows, from high potential to low potential. Imagine two tanks containing water, each of which has water at high pressure. Using some method, could be using a water pump or whatever, the pressure in both tanks may or may not be same. If the two tanks are joined by a thin pipe, will the water flow through the pipe? If yes, in which direction? It is easy to understand that if the pressure in two tanks is the same, no matter how high, the water will not flow in either direction. If there is difference in pressure, water will flow from high pressure to low pressure. Whichever tank has got higher pressure, water will flow from that tank to the other tank. Similarly, if we have two reservoirs of charge at some potential and we join the two using a conducting wire, there will be no current flowing in the wire if both potentials are equal, no matter how high the potential may be. If the two potentials are not the same, current will flow from high potential to low potential. Coming back to example of two tanks of water, each at some pressure, while the pressure is not equal. The two tanks are joined using a thin pipe. How fast the water will flow? The water flow rate will be higher if the pressure difference, the difference of pressure, is higher, and lower if the pressure difference is lower. If the two pressures are 5 units and 2 units, which means a difference of 3 units, the flow rate will be more than if the pressures are 95 units and 93 units. That is a difference of 2 units. What matters here is the difference in pressure and not the actual pressure in each tank. Similarly, for electricity, what matters is the difference in potential and not the actual potential of each supply of charge. And the current flow will be higher if the difference is higher. Hence, it is common practice to specify only the potential difference between any 2 points of a circuit and not the actual potential of each point. The potential difference is measured in volts, same as for potential. Potential is measured in volts, and hence the potential difference is also measured in volts. The potential difference is sometimes loosely called voltage. Potential difference between two supplies of charge is called the voltage between the 2 points, between the 2 wires. A difference among the water and charge analogy. There is, however, a difference among the water and the charge analogy. Water has weight and mass, while charge has no weight and no mass. Because of this, water flows from high to low. High, when I say, I mean gravitationally the high point. Water flows from high to low. Charge flow is not dependent on the physical height. How to create 2 tanks of water with a pressure difference between them? One of the possible methods could be using a water pump. A water pump is a device which forces water to flow from lower pressure. This side will have water at lower pressure to higher pressure. The electrical equivalent of a water pump is a battery. It forces charge to flow from low pressure, low potential to high potential. Or in other words, if you put the battery between 2 points, it will generate a potential difference between the 2 points by pulling the charge out of the low potential and pushing it into the high potential point. Notice, other than a battery, wherever charge is allowed to free flow, it will flow from high potential to low potential. But the moment you put a battery, it's a special device which pulls the charge from the low potential and pushes it into a point of high potential, just like a water pump which pulls the water from a reservoir or from a supply which is having low pressure and pushes it into the high pressure.